2, 3, 4. Sugador, sugador, sugato. Ah, 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 sugador, sugador, sugato. Sine, opposite hypotenuse, sine, opposite hypotenuse, sine, opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, tangent, opposite adjacent, tangent, opposite adjacent, alongside.
Okay, that was really annoying, but a good way to start video 19. Here we go. Let's start actually using trig to find missing sides. Take out those geobooks. Okay, so make sure you write your title. There's no vocab this time, so we're just going to be finding missing sides of right triangles using trig. So you're going to need a calculator. If you don't have one, it's okay for now. You'll use the one in our classroom. But if you take a look at this calculator, this is the type that we have in our classroom. Notice the sine, cosine, and tangent buttons. We're going to be using those to find our missing sides. So when I say push sine on your calculator, you would actually push this button. Okay, and then cosine and tangent. Okay, so let's take a look at what we have to find. We have our right triangle. We have to find side BC, which is labeled A. We have a 43-degree angle and one side, 11. So first thing you want to do is label your hypotenuse, the opposite side, and the adjacent side. So the hypotenuse is kind of easy to find. It's across from the 90-degree angle. Okay, then we have our angle here, so opposite would be over here. So that's our opposite side. And then remember, adjacent is right next to the angle. That's our adjacent side. So recall our SOHCAHTOA. Helps us remember. I'll write it again. So we need to decide which one should we use, sine, cosine, or tangent. Sine, cosine, or tangent. So if you look, we're given the adjacent side, and we need to find the opposite side. So we need to use the one that uses opposite and adjacent, since those are the two that we're working with. So we're going to go ahead and do tangent. So you write tangent of 43 degrees equals opposite, which is the letter A, over adjacent, which is 11. Okay, so now what you do is you use your calculator. You have to figure out what is tangent of 43 degrees. So you'll punch the tangent key, then type in 43 and hit equals. Let me go ahead and do that. Okay, so I used my calculator and I got that tangent of 43 degrees is 0.9325. And that'll equal A over 11. Well, how do you solve this equation? Let me go ahead and put a spot for my answer. A equals. Okay, so how would you solve this equation to get A by itself? Well, hopefully you're thinking that we will multiply both sides by 11. And that'll tell us what A equals. So A is going to equal whatever this number is times 11. And we end up getting 10.2, I'll go ahead and round to the nearest hundredths, 10.26. So our missing side is 10.26. Okay, so that's how you find the missing length of a right triangle using trig. It'll take us some practice, and I know you might not have a calculator on you right now, but it's okay. We'll do more in class. Okay, let's look at number 2. Okay, so first thing you want to do is go ahead and label your sides. So the hypotenuse is hopefully an easy side to find. It's across from the right angle. So this is our hypotenuse. Then you find the one opposite your angle. So this is opposite. And then next to it would be our adjacent side. So take a look at what we're using. We have the hypotenuse and the adjacent. We don't need the opposite. So which of our trig ratios uses adjacent and hypotenuse? Well, if you're thinking cosine, adjacent and hypotenuse, you're right. So what we do is we write cosine of 40 degrees equals adjacent, which is x, over hypotenuse, which is 13. Okay, now we just have to solve this. Let me go ahead and put a spot for my answer. X equals, okay, so we're going to multiply both sides. Actually, let's go ahead and figure out cosine of 40 first. That'll be a little bit easier. Cosine of 40 in my calculator equals 0.7660. Now I just have to solve this equation. So to get x by itself, we multiply both sides by 13. Those cancel out. So I went ahead and just left the 0.7660. It kept going. I left that in my calculator. So I'm going to take that number and go ahead and multiply by 13. And I get 9.96. So we found our missing side of 9.96. So that's x. That's easy, right? Let's try one more. Okay, so we're trying to find y this time, so let me go ahead and put a spot for my answer before I forget. Y equals. Okay, so we need to label our sides. 15 is our hypotenuse. Across from the 57 degrees is our opposite side. And then this one would have to be adjacent. So we are using opposite and hypotenuse. So which one of our trig ratios uses opposite and hypotenuse? Hopefully you're thinking sine is opposite over hypotenuse. So we set up our trig equation. So sine of 57 degrees equals y opposite over hypotenuse. Okay, so we go ahead and multiply both sides. Actually, I keep wanting to do that, but I'm going to go ahead and figure out what is sine of 57. Sine of 57 degrees is 0.8387. That equals y over 15. Okay, to get y by itself, we need to multiply both sides of the equation by 15. So those cancel out. And I get y equals, I left that big long number in my calculator, so it's actually been rounded, but I'm going to go ahead and multiply by 15. And we get 12.58. That's the length of our missing side. So y is 12.58. Okay, well it can get a little more challenging than this, and I'll show you some more examples in class. Okay, just joking, we're going to do one more problem together. We're going to go ahead and get problem 4 done. Number 4 is a little more challenging, so let's go ahead and get a spot down here for our answer. We're going to be solving for x. So same way, we're going to start the same way. We're going to label our sides. So side x is going to be our hypotenuse because it's across from the right angle. This is the angle we're using. So across from that would be our opposite. And then here we have our adjacent. Okay, well the two sides that we're working with would be the hypotenuse and the opposite side. So which one of our trig ratios uses opposite and hypotenuse? Well, hopefully you're thinking sine, opposite over hypotenuse. So we don't need the adjacent side. So let's go ahead and set up our trig equation. So we're going to use sine of our degree, 52, is equal to opposite, which is 12, over hypotenuse, which is x. Okay, remember we go ahead and use our calculator. We figure out sine of 52 equals, and I get 0.7880 is equal to 12 over x. Well, this one's a little different than the other ones that we looked at. Notice that our variable is down here, so it's going to require a little bit of extra work. What we're going to do is go ahead and multiply both sides by x, because we don't want to deal with that fraction anymore. So we're going to multiply both sides by x, and we end up with 0.7880x equals 12. Well, if we want to get x by itself, we're going to have to go ahead and get rid of that 0.7880. So we're going to divide both sides by 0.7880. Divide both sides. Okay, so it just requires a little bit more work, but we're able to get x by itself. So I'm going to divide 12 by 0.7880, and I get that x equals 15.23 when I round to the nearest hundredth. Okay, so when x ends up in the denominator in your equation, it just requires a little bit more work, okay, because you had to get your x to the other side, and then you had to get rid of the number attached to x by dividing both sides. Okay? Well, I hope you have an awesome day. See you in class.